The next major AI race may not happen inside a chat window. It may happen on factory floors, in warehouses and hospitals, where software has to control machines in the unpredictable physical world. In July, Nvidia announced partnerships with leading Japanese robotics companies, including Fanuc and Yaskawa Electric, to develop what the industry now calls physical AI, models that perceive, plan and act through robots. The idea sounds simple. Give a robot cameras, sensors, and an AI model, then let it understand instructions and adapt. In practice, every movement has consequences, and every mistake can damage equipment or people. Japan is a credible place to test this shift. It has world-class manufacturers, deep robotics expertise, and an aging population that has made labor shortages a long-term economic constraint. The country is also building the computing foundation. Nvidia says a Japan-linked physical AI project will use tens of thousands of its next-generation chips and a large dedicated power supply for training and simulation. That matters because robots need more than a clever model. They need enormous amounts of simulated experience before they can be trusted to operate around costly machinery or vulnerable people. A chatbot can produce a bad sentence and be corrected. A robot arm that misjudges distance can crush a component, stop a production line, or injure someone standing nearby. So physical AI begins in virtual environments. Engineers create digital factories, warehouses, and work cells where millions of movements can be tested without damaging real equipment. Simulation also lets companies manufacture rare failures. A robot can practice dropped objects, blocked paths, strange lighting, and unexpected human movement long before those events happen in a real facility. Then comes the difficult transfer from simulation to reality. Real floors flex, cameras become dirty, components vary, and humans behave in ways no training environment can completely predict. This gap is why the strongest near-term applications are usually narrow. A machine may become excellent at moving one family of parts, inspecting one product, or navigating one controlled warehouse. Fanuc and Yaskawa already sell industrial systems built around reliability and repeatability. The new proposition is that AI can make those machines more flexible without sacrificing the precision customers depend on. If that works, manufacturers could reconfigure production faster. A robot trained through demonstrations and simulation might handle a new product without months of handwritten programming. Warehouses are another obvious target. Mobile robots can already move shelves and pallets, but AI could help them cope with changing layouts, mixed objects, and tasks that were previously too variable. Hospitals and care settings offer a more sensitive opportunity. Machines could transport supplies, support rehabilitation, or perform routine logistics, but safety and dignity matter more than impressive demonstrations. The home is harder still. A domestic robot must operate around children, pets, stairs, clutter, fragile objects, and people who never agree to behave like a controlled test case. That is why humanoid robots receive attention but may not dominate early deployment. Purpose-built machines are often cheaper, safer, and better at a single useful job. The real commercial question is not whether a robot can complete a task once. It is whether it can repeat that task thousands of times with predictable maintenance, energy use, and insurance costs. Physical AI also changes where computing happens. Some decisions can be trained in giant data centers, but a working robot often needs local processing because waiting for the cloud introduces delay and dependence on connectivity. This creates a new market for edge processors, sensors, industrial networks, and secure software updates. The robot is only the visible end of a much larger technology stack. Nvidia benefits from that stack. It can sell training chips, simulation software, networking, and smaller processors inside machines, making physical AI a way to extend demand beyond conventional data centers. Japan benefits for a different reason. If it can combine domestic robotics companies with advanced AI infrastructure, it may strengthen manufacturing competitiveness while easing specific labor shortages. But the labor argument needs care. Automation can remove dangerous or repetitive work, yet it can also reorganize jobs, reduce bargaining power, or create new monitoring pressures. History suggests technology rarely replaces an entire occupation in one clean step. More often it automates tasks, changes staffing levels, and increases the value of workers who can maintain or supervise the new systems. Cost remains a major barrier. A polished demonstration does not include every integration bill, safety assessment, production stoppage, replacement part, and software failure that appears over years of operation. Reliability is another barrier. A system that works 99% of the time may sound impressive, but one failure in every 100 actions can be unacceptable on a busy production line. Regulation will therefore matter. Industrial robots already operate behind barriers and safety systems. More adaptive machines working beside people will require clear responsibility when perception or planning fails. Cybersecurity matters as well. A connected robot is a computer with motors. Compromised software could expose production data, disrupt operations, or turn a digital intrusion into physical damage. The strongest bull case is not a sudden army of general-purpose humanoids. It is thousands of specialized machines becoming easier to train, reconfigure, and deploy across existing industries. The strongest bear case is that companies mistake impressive prototypes for reliable products, spend heavily on integration, and discover that human flexibility remains cheaper for many tasks. Both outcomes can be true at once. Physical AI may create valuable systems while individual robot programs fail, just as the broader AI boom can succeed without every investment earning a return. The signal to watch is deployment quality rather than demonstration quality, hours worked without intervention, safety incidents, maintenance cost, and whether customers order a second fleet after using the first. Japan's partnerships give the industry a serious proving ground. They connect advanced chips with manufacturers that understand what factories demand, not just what looks impressive on a stage. If the projects work, the next AI platform will not simply answer questions. It will move material, inspect products, and perform useful physical work in places built for people and conventional machines. The robot race has started, but the winners will not be the companies with the most human-looking machine. They will be the ones that make physical intelligence dependable enough to become ordinary.